Good morning, boys and girls, and welcome back to another day of derivative rules. Okay, today we're going to be talking about the product and quotient rule. We had a problem like this in our last lesson, and we said what we had to do with something like this was if you had two functions multiplying by each other, the only way we had to deal with it as of so far was to multiply everything together. So if I multiplied everything together, I would get x cubed minus 3x squared plus x minus 3. And then once I had it all together, I could take the derivative of this by using our power rule and our constant multiple rule. So, f prime of x equals, for the power rule, you bring the power down in front, and then you subtract 1 from the exponent. So there's our power rule. If you had a coefficient, you multiply in front, and then go down by 1, plus 1, and then the derivative constant is 0, so that disappeared all the way. So that was the only way we had to take the derivative of something like this so far. Now we're going to add what we call another way to do this problem called the product rule. When you have things multiplying together, you can take the derivative using the product rule. Okay, so here's our product rule, both written out mathematically and also in words. Okay, if I'm going to take the derivative of two functions that are being multiplied together, what you're going to do is you're going to take the derivative of the first function times the second plus the first function times the derivative of the second. And again, I say that. That's why I took time to type this out for you and everything. I say that every time I take the derivative using the product rule. The derivative of the first times the second plus the first times the derivative of the second. Okay? Every time you take the derivative, you're going to want that little saying in your head when you use the product rule. The derivative of the first times the second plus the first times the derivative of the second. Okay? So if we try to apply this to the problem we just did right above here, it'll look a little bit different when I find f prime. I'm not going to run out of room here. But I'm going to take the derivative of the first function. So this is the first function, x squared plus 1. So the derivative of that is 2x. The derivative of the first times the second, x minus 3, plus the first, x squared plus 1, times the derivative of the second, would just be 1. Okay? And that's what I'm saying. Like in this case, I probably would just, if you just give me this problem, I probably would have double distributed the way we did and then used the power rule. Like you see, I have to distribute here anyway. But if I do this, 2x squared minus 6x plus x squared plus 1, you can still see that we're going to get to 3x squared minus 6x plus 1. I still get the same derivative, just using a different method. There'll be other times down the road when I have to use this and I'm not able to multiply out. Like let's say if one of those functions was sine x. Now you can't distribute. Sometimes it's just algebraically, the work's going to be nicer if I don't multiply out. Okay? For tonight's homework, I'm going to ask that you do use the product rule, even if you could multiply out, because that's the whole point behind tonight is to practice the product and quotient rules. All right? So let's do some of these with an example or two. Okay, so on this problem, you totally could distribute and then take the derivative, and it probably would be easier than what we're about to do. But the point behind tonight's homework is to practice the product rule. So that's what we're going to do. So if I want to find the derivative of f, I got two functions multiplying by each other. One being 3x to the fourth, the other one being 2x squared minus 1. All right, so if I do this, I need to take the derivative of the first. Multiply the exponent times the coefficient, take away 1 from the exponent, times the second, 2x squared minus 1, plus the first, 3x to the fourth, times the derivative of the second, 4x. And now, I just found the derivative. That is the derivative. You could stop on a free response question right there. However, I'm going to say most of the time, these are multiple choice, so you want to make your answer match. So please, like tonight on the homework again, make the answer match the one in the back of the book. All right, so if I do that, 12 times 2 is 24x to the fifth. If I add my exponents, minus 12x to the third, plus 12x to the fifth. And then if I put this together, we get the derivative is 36x to the fifth minus 12x cubed. And that's probably what you would find on a multiple choice question. Okay, here we go on number 2. Here is one where you would have to use the product rule. There is no way, even if I distribute the e to the w, which I guess you could do, you're still going to have a product of e to the w times w cubed that you need to use the product rule on. So there is no getting around the product rule in this question. We have to do it. So we might as well just jump in and start right here. So g prime of w, make sure you're using good notation. Tell people when you're finding the derivative, okay, or when you're talking about the real function. Derivative of the first, okay, derivative of e to the w is e to the w. Okay, derivative of e to the x is e to the x. Derivative of the first times the second plus the first times the derivative of the second. Right there. Okay. Now again, technically we found the derivative, but we probably would need to simplify this somewhat. I'm not sure what they're going to do here. I said I'm not sure what they're going to do here because I could multiply that with that e to the w, and then I'm going to get a bunch of like e to the w cubes, e to the w, 3w squared, which doesn't make this a prettier answer really. And one of our common things that we will do as we get moving on later down when we start playing with derivatives in the next unit is we will factor out a GCF at this point a lot. So that's one of the things we want to start getting used to doing. And I'm going to guess, we'll check here in a second, I'll check the answer to the book, but I'm going to guess that they're going to factor out an e to the w out of both these things. And that would leave us with w cubed plus 3w squared, if I rearrange it a little bit, minus 1. Okay? And let me check the book here. Yep, and exactly. That is the answer that they have as theirs. It's kind of a prettier answer. And the more you do these, the more you'll kind of get used to the way your answers you're going to want them to look. Again, just make sure you're checking your answers in the back of the book and try to make your answers match. Okay, there's a lot of different ways we could have got to get into the same spot. I'm just trying to get there the quickest and fastest. All right, now let's talk quotient rule. Okay, and here is the quotient rule. It looks a little something like above here, where we're taking the derivative of a function divided by another function. Okay, we're dividing, so quotient. And here is it written out. G of x times f prime of x minus f of x times g prime of x all over g of x squared. Or we have, again, the much handier saying low d high, so low function, derivative of the high function, minus high d low, minus the high function times the derivative of the low function, square the bottom, and off we go. Low d high minus high d low, square the bottom, and off we go. One of the best sayings for, a calculus rule. I like that one a lot. All right, so let's go ahead and let's use this. Maybe just one more clarifier here real fast. This all, I guess, is assuming that g of x does not equal 0, right? Because if it was 0, then it would be undefined and we can't do anything. So that's just the little qualifiers we got to put on this. Okay, let's do a few quotient rule problems, and then we will, continue on with our day. We'll be done. Okay, so here we go. F of x is x to the third minus 4x squared plus x all over x minus 2. We want to find f prime, or the derivative of f. So we're going to use the quotient rule for dividing functions. So if we do that, low d high, so low is x minus 2. D high is the derivative of the top, so 3x squared minus 8x plus 1. Minus, I'm running out of room here. I kind of need, I can't shrink that up, but minus high, x cubed minus 4x squared plus x. D low, square the bottom, and off we go. Low d high minus high d low, square the bottom, and off we go. All right, there we go. So again, technically, I've taken the derivative. Yay, we're done. Now it just becomes a fact of, do I have to make it match something? All right. Now we generally are going to have to make it match something. Question is, how are we going to do that? Again, a lot of times you might try to factor stuff out, like we talked about in the previous problem. But I'm not really seeing that I can factor it, so I think the only thing we'll be able to do here is just multiply out the top, which does not look like a lot of fun, but we can do it. If I double distribute in the front here, I'm going to get 3x cubed minus 8x squared plus x minus 6x squared plus 16x minus 2. And then in the back, thank goodness, I just have to distribute that negative and the 1. So negative x cubed plus 4x squared minus x. All of this is over x minus 2 squared. I'm just going to leave it like that. Generally, we play around more of the tops and the bottoms we kind of leave. Again, when we're done, we'll check the answer in the book to see if we did it correctly or not. Now I got 3x cubed minus x cubed is 2x cubed. Cross those out. Then I got negative 8x squared minus 16x squared is negative 14x squared plus 4x squared is plus 10x squared. So I cross those out. And then we got x plus 16x is 17x minus x is back to 16x. And then I cross all that stuff out. Keep track of all my terms here. And then it looks like I just have a minus 2 left. All of this over x minus 2 squared. All right, let me check the answer here. That's it. That's the one they have in the back of the book. So we can leave it like that. Again, just make sure when you're taking the derivative, make sure that you are notating that you took the derivative. Okay, there's so many times in your guys' tests that you guys lose points because you take the derivative without telling me, and now I can't give you points because you're not telling me it's the derivative. Use proper notation, please. All right, another one just with a quotient rule. I'm going to just quickly speed through this. We want to find the derivative here. So g prime of x is low 2e to the x plus 1, d high 2e to the x minus high 2e to the x minus 1, d low 2e to the x, square the bottom 2e to the x plus 1 squared. Square the bottom and off we go. Okay. All right, now I just need to simplify this a little bit. And it looks like if I do this, I'm going to get 4e to the x plus 2e to the x. I'm distributing that top part right there. Then minus 4e to x minus 2e to the x. Looks like I did something weird here. All right, I found my mistakes real fast. 4e to the should be 2x and 4e to the 2x. And then I forgot to distribute my negative back here. Okay? All over 2e to the x plus 1 squared. And now when I put like terms together, these kill each other off. And so I get 4e to the x over 2e to the x plus 1 squared. And there's my derivative. Yay! All right, one more we're going to try to squeeze in here. Okay, for our last one, we're given a function, and we want to write the equation of the tangent line at the given point. So again, whenever you get the instructions, write the equation of the tangent line. You need to find the slope and a point. Okay, and again, that slope is generally, slope of the tangent line is synonymous with the derivative, so that's going to come with the derivative. And then the point, a is 3, that is my x-coordinate, and I'm going to have to fill in the rest of that point. Okay. Okay, so over on the right here, I just showed my work for finding the y-coordinate. I'm just going to plug 3 into the function, and so I get 2 when I do that. So I now have my point. Now I just got to work on finding the slope, and again, I'm going to do that through the derivative. Okay, to find the slope, again, we use the derivative. So I have to do low d high minus high d low, square the bottom, and off we go. Distribute in the front to simplify. Distribute that negative in the back to simplify. Be careful with your algebra. The x's kill each other off, and so I get negative 4 over x plus 1 squared. Okay. Now I need to evaluate my derivative at 3. So this is negative 4 over 3 plus 1 squared, or negative 4 over 16, which is negative 1/4. And so now I have my slope and my point, so I'm ready to go ahead and write the equation of the tangent line. It would be y minus 2 is negative 1/4 times x minus 3. And again, generally speaking, I'm going to stop right there. Don't do more than you have to. Just leave it like that. All right, thanks, boys and girls. Have a great day.